Hi everyone, here is the M4 practice hackathon. At the beginning, I examined the descriptive statistic of several specific columns in the dataset and found some extreme values, such as age larger than 100. After removing these extreme values, I proceeded with feature engineering. I created several new financial ratio features, such as loan to income and credit history to age ratios, to better reflect repayment ability. I also added interaction terms and log transformations to capture nonlinear relationships and reduce skewness. Besides, I apply binning to income and credit scores to help the model detect structural efforts. When building models, I figure out the dataset is imbalanced, so I try two ways to adjust it. The first method is mode, using the light GBM model. In the second one is using the parameter scale pulse way. In addition, I also use stratified k-fold cross-validation when searching the best combination of parameters. The stratified k-fold cross-validation makes the predictions more stable and accurate compared to single train test split. To make sure the performance of light GBM model, both Grid Research CV and Randomized Search CV are used to tune the hyperparameters. Randomized Search CV is kept in the code because of its efficiency. It computes more quickly. After tuning, the model performs better with F1 score about 0.84. I better improve the F1 score of prediction by applying AutoML and AutoGluon packages, which could combine different types of model like GBM, CatBoost, and XGBoost. GBM model solid boosting performance, while XGBoost achieved a higher F1 score due to better regularization and optimization, leading to a stronger balance between precision and record in risk detection. CatBoost perform competitively, especially with categorical features, offering stable performance and easier handling of complex financial data in real business settings. The model generated by AutoGluon performs better after I tested different probability thresholds between zero point 0.3 and 0.69 to find the one that maximized the F1 score on the training set. By selecting the threshold with the highest F1 score instead of using the default zero point 0.5, I better balance precision and record. F1 score directly relates to false positive and false negative because it combines precision and recall. In a loan approval setting, a false positive means approving a risky borrower who later defaults, which causes financial loss. A false negative means rejecting a reliable borrower, which leads to lost profit and missed business opportunities. And I also draw a learning curve. The learning curve shows a noticeable gap between training and validation F1 scores, indicating model overfitting. While the model fits the training data almost perfectly, the validation F1 is lower, but still steadily improving. This suggests that the model has not yet reached its performance limit. To improve performance, I can tune the probability threshold to directly optimize F1. And I also could increase L1 regularization to reduce overfitting and potentially add more training data to enhance generalization. Finally, if I have more time and resources, I will further improve the classifier by incorporating external datasets. For example, adding microeconomic indicators such as unemployment rate, inflation rate, and GDP growth could significantly improve predictive accuracy, since economic downturns strongly affect loan default risks. I will also integrate credit-bureau data such as detailed repayment history or total outstanding debt to better capture borrowers' financial behavior.